The National Electrical Code, or NEC, does not mandate that all wiring in a greenhouse be wet location rated. Article 100 of the NEC defines a wet location as an area subject to saturation with water or other liquids. Examples include shower stalls, washrooms, and outdoor locations exposed to rain. Article 680 specifically addresses wiring and equipment in greenhouses, but it doesn't require all wiring to be wet location rated unless it is indeed in a wet location. In areas directly exposed to water, such as irrigation zones or misting areas, all wiring must be wet location rated. In damp locations, areas that are only occasionally exposed to moisture, such as near a sink or a hose bib, may require wet location rated wiring if there's a potential for water to drip or splash. In dry locations where moisture is not present or only present in minimal quantities, wet location rated wiring is not a requirement. Given that the greenhouse is hand watered, the boxes below 8 feet are rain-tight. Standard electrical metallic tubing or EMT and metal-clad or MC cables are used above 8 feet, and wet location light fixtures are used for rust prevention. The following can be inferred. Firstly, below 8 feet, the wiring is unlikely to be exposed to moisture, so wet location rating is not a requirement. Secondly, above 8 feet, while the wiring may be exposed to occasional moisture during watering, it is still unlikely to be saturated or continuously wet. Therefore, a wet location rating may not be necessary, although it could provide additional protection against rust. It is recommended to consult with a qualified electrician or inspector to determine if wet location rated wiring is required for the specific greenhouse based on the actual conditions and local code requirements. The NEC provides guidelines to ensure electrical safety, and understanding the specific requirements for different types of locations is crucial. Proper installation and adherence to the code prevent electrical hazards and ensure the longevity and reliability of the electrical system. Consider factors such as humidity, condensation, and potential water exposure when determining the appropriate type of wiring for a greenhouse environment. The use of appropriate fittings and connectors is also essential to maintain the integrity of the wiring system and prevent moisture from entering electrical boxes or conduits. Additionally, regular inspections and maintenance can help identify any potential issues and ensure that the electrical system continues to meet safety standards. When installing or modifying electrical systems in a greenhouse, it is essential to follow all applicable codes and regulations. Local jurisdictions may have additional requirements that must be met. It is also crucial to use qualified electricians and inspectors who are familiar with the specific challenges and requirements of greenhouse environments. Improper wiring or installation can create a safety hazard and potentially lead to electrical fires or other accidents. Therefore, it is always best to err on the side of caution and consult with professionals who can provide expert guidance and ensure that the electrical system is installed correctly and safely. By following these guidelines and working with qualified professionals, one can ensure that the electrical system in the greenhouse is safe, reliable, and compliant with all applicable codes and regulations. The goal is to provide a safe and productive environment for growing plants while minimizing the risk of electrical hazards. Understanding the different types of wiring and their applications is essential for making informed decisions about electrical installations. Firstly, conductors are typically made of copper or aluminum, and they are available in various sizes and insulation types. The size of the conductor determines its ampacity, or current carrying capacity, which must be sufficient to handle the load it will be carrying. Secondly, the insulation type determines the conductor's suitability for different environments, such as wet, damp, or dry locations. Thirdly, cables consist of multiple conductors bundled together and protected by an outer jacket. Common types of cables include non-metallic or NM cable, which is used for dry indoor locations, underground feeder or UF cable, which is suitable for direct burial in the ground, and armored or AC cable, which provides mechanical protection for the conductors. Conduit is a rigid or flexible tube used to protect conductors from physical damage and environmental factors. Electrical metallic tubing, or EMT, is a thin mold conduit commonly used in commercial and industrial applications. Rigid metal conduit or RNC is a heavy-walled conduit used in areas where greater mechanical protection is required. Flexible metal conduit or FMC is a flexible conduit used for connecting equipment that may vibrate or move. When selecting wiring and cabling for a specific application, it is important to consider the following factors. Firstly, the ampacity of the conductors must be sufficient to handle the load they will be carrying. Secondly, the insulation type must be appropriate for the environment in which the wiring will be installed. Thirdly, a wiring must be protected from physical damage and environmental factors by using appropriate conduits and fittings. Fourthly, all wiring and cabling must comply with the NEC and local electrical codes. In addition to selecting the right wiring and cabling, it is also important to install them correctly. A proper installation can lead to electrical hazards and equipment failures. Firstly, all wiring connections must be made using approved connectors and fittings. Secondly, all wiring must be properly supported and secured to prevent strain on the conductors. Thirdly, all wiring must be grounded to provide a path for fault current to flow back to the source. Fourthly, all electrical boxes and enclosures must be properly sealed to prevent moisture and dust from entering. Regular inspection and maintenance of the electrical system are also essential to ensure its continued safety and reliability. Following are some common maintenance tasks that should be performed regularly. Firstly, check for loose connections and tighten them as needed. Secondly, inspect wiring for damage such as cuts, abrasions, or corrosion, and replace damaged wiring immediately. Thirdly, test ground fault circuit interrupters or GFCIs to ensure that they are functioning properly. Fourthly, clean electrical boxes and enclosures to remove dust and debris. By following these guidelines, one can ensure that the electrical system is safe, reliable, and compliant with all applicable codes and regulations. Remember, it is always best to consult with a qualified electrician for any electrical work that is beyond one's expertise. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock hazards. The grounding system consists of the following components. Firstly, the grounding electrode, which is typically a metal rod or plate buried in the ground. Secondly, the grounding electrode conductor, which connects the grounding electrode to the electrical system. Thirdly, the equipment grounding conductor, which connects the metal parts of electrical equipment to the grounding system. The grounding electrode must be installed in accordance with the NEC. The NEC specifies the type and size of grounding electrode that must be used, as well as the minimum depth at which it must be buried. The grounding electrode conductor must also be sized according to the NEC. The equipment grounding conductor must be run with the circuit conductors and must be connected to all metal parts of electrical equipment that are likely to become energized. Ground fault circuit interrupters or GFCIs are devices that are designed to protect people from electrical shock hazards. GFCIs work by monitoring the current flowing through a circuit. If the current flowing into the circuit differs from the current flowing out of the circuit by more than a few milliamperes, the GFCI will trip and interrupt the circuit. GFCIs are required in many locations such as bathrooms, kitchens, and outdoor areas. They are particularly important in areas where there is a risk of water exposure. Surge protection devices or SPD are devices that are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD work by diverting excess voltage away from the equipment and back to the source. SPD are available in various types and sizes. The type and size of SPD that is needed will depend on the type of equipment being protected and the severity of the voltage surges that are expected. Electrical safety is everyone's responsibility. By following safe electrical practices, one can help to prevent electrical accidents and injuries. Here are some basic electrical safety tips. Firstly, never work on electrical equipment unless you are qualified to do so. Secondly, always turn off the power before working on electrical equipment. Thirdly, use insulated tools when working on electrical equipment. Fourthly, never overload electrical circuits. Fifthly, keep electrical equipment away from water. Sixthly, inspect electrical cords and plugs regularly for damage. Seventhly, replace damaged electrical cords and plugs immediately. Eighthly, never run electrical cords under rugs or furniture. Ninthly, use ground fault circuit interrupters or GFCIs in areas where there is a risk of water exposure. Tenthly, install surge protection devices or SPD to protect electrical equipment from voltage surges. By following these electrical safety tips, one can help to create a safe electrical environment for oneself and others. Electrical codes and standards are constantly evolving to reflect new technologies and best practices. It is important to stay up to date on the latest codes and standards to ensure that electrical systems are installed and maintained safely and effectively. The NEC is updated every 3 years. It is important to purchase the latest edition of the NEC and to familiarize oneself with the changes that have been made. In addition to the NEC, there are also various other electrical codes and standards that may be applicable depending on the location and type of electrical system. It is important to consult with a qualified electrician or electrical inspector to determine which codes and standards are applicable to the specific project. Continuing education is essential for electricians and other electrical professionals. There are many opportunities for continuing education, such as seminars, workshops, and online courses. By participating in continuing education, electrical professionals can stay up to date on the latest codes and standards, as well as learn about new technologies and best practices. This helps them to provide safe and effective electrical services to their customers. When in doubt, always consult with a qualified electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and effectively. They can also help to ensure that the electrical system complies with all applicable codes and standards. Remember that safety is paramount when dealing with electricity. Always take precautions and follow safe practices to prevent electrical accidents and injuries. Electrical systems should be designed to accommodate future growth. Plan for additional circuits and capacity to avoid overloads and the need for costly upgrades later on. Consider the long-term needs of the greenhouse and design the electrical system accordingly. Electrical panels should be easily accessible for maintenance and repairs. Ensure that there is adequate space around the panel for electricians to work safely. Avoid obstructing access to the panel with plants or equipment. Proper labeling of circuits is essential for troubleshooting and maintenance. Clearly label each circuit breaker with the corresponding equipment or area that it serves. This will save time and effort when identifying and resolving electrical issues. Use weatherproof enclosures for all outdoor electrical components, such as outlets, switches, and lighting fixtures. Weatherproof enclosures protect electrical components from moisture, corrosion, and other environmental factors. This helps to extend the life of the electrical system and prevent electrical hazards. Regularly inspect the electrical system for signs of damage or wear. Look for frayed wires, cracked insulation, loose connections, and other potential problems. Address any issues promptly to prevent them from escalating into more serious hazards. Use appropriate wiring methods for the specific application. For example, use underground feeder or UF cable for underground wiring and electrical metallic tubing or EMT conduit for exposed wiring. Using the correct wiring method helps to ensure the safety and reliability of the electrical system. Install surge protection devices or SPD to protect sensitive electronic equipment from voltage surges. Voltage surges can damage or destroy electronic equipment such as computers, sensors, and control systems. SPD can help to protect this equipment and prevent costly repairs or replacements. Consider using energy-efficient lighting and equipment to reduce energy consumption and save money. LED lighting, for example, is much more energy efficient than traditional incandescent lighting. Using energy-efficient equipment can also help to reduce the load on the electrical system and extend its lifespan. Properly size the electrical service to meet the needs of the greenhouse. The electrical service must be large enough to handle the total load of all electrical equipment that will be used in the greenhouse. Oversizing the service can waste money, while undersizing it can lead to overloads and equipment failures. Consult with a qualified electrician to determine the appropriate size of the electrical service for the greenhouse. Consider the use of renewable energy sources such as solar panels to generate electricity for the greenhouse. Renewable energy sources can help to reduce reliance on fossil fuels and lower energy costs. Solar panels can be installed on the roof of the greenhouse or in a nearby location. Implement a regular maintenance schedule for the electrical system. This should include inspecting wiring, tightening connections, testing GFCIs, and cleaning electrical panels. Regular maintenance can help to identify and address potential problems before they become serious hazards. Keep detailed records of all electrical work that is performed on the greenhouse. This should include the date of the work, the type of work that was performed, and the name of the electrician who performed the work. Detailed records can be helpful for troubleshooting and maintenance purposes. Provide adequate ventilation for electrical equipment to prevent overheating. Overheating can damage electrical equipment and shorten its lifespan. Ensure that there is adequate airflow around electrical panels, transformers, and other heat-generating equipment. Use appropriate safety signage to warn people of potential electrical hazards. This should include signs indicating the location of electrical panels, the presence of high voltage, and the need to use caution when working the electrical equipment. Store flammable materials away from electrical equipment. Flammable materials can ignite if they come into contact with hot electrical components. Store flammable materials in a safe location away from electrical panels, transformers, and other electrical equipment. Train employees on basic electrical safety procedures. Employees should be trained on how to identify and report electrical hazards, how to use electrical equipment safely, and how to respond to electrical emergencies. Proper training can help to prevent electrical accidents and injuries. Conduct regular safety audits of the electrical system. Safety audits can help to identify potential hazards and ensure that the electrical system is in compliance with all applicable codes and standards. Address any issues that are identified during the safety audit promptly. Develop an emergency plan for electrical outages. The emergency plan should include procedures for safely shutting down equipment, providing backup power, and communicating with employees and customers. Having an emergency plan in place can help to minimize the impact of electrical outages. Cooperate with local utility companies to ensure a reliable power supply. The local utility company is responsible for providing a reliable power supply to the greenhouse. Cooperate with the utility company to ensure that the electrical system is properly connected and that any potential issues are addressed promptly. Consider the use of smart technology to monitor and control the electrical system. Smart technology can be used to monitor energy consumption, detect potential problems, and control lighting, heating, and cooling systems. This can help to improve energy efficiency and reduce operating costs. Work with qualified professionals for all electrical work. Electrical work should only be performed by qualified professionals who have the knowledge, skills, and experience to do it safely and effectively. This helps to ensure that the electrical system is installed and maintained properly and that it complies with all applicable codes and standards. By following these guidelines, one can ensure that the electrical system in a greenhouse is safe, reliable, and efficient. Remember that safety should always be the top priority when dealing with electricity. Electrical safety and compliance are crucial for the safe and efficient operation of any greenhouse. By following the guidelines and recommendations outlined, greenhouse owners can ensure that their electrical systems meet all applicable codes and standards, while also providing a safe and productive environment for their plants and employees. Remember to consult with qualified electricians and inspectors for any electrical work or concerns, and to prioritize safety at all times. The information provided is intended as a general guide and should not be considered a substitute for professional advice. Local codes and regulations may vary, so it is essential to consult with local authorities and qualified professionals to ensure compliance. The electrical system is the backbone of any greenhouse operation, and it is essential to ensure that it is properly designed, installed, and maintained. A well-designed electrical system can provide reliable power for lighting, heating, cooling, and other essential equipment, while also minimizing energy consumption and operating costs. Regular maintenance and inspections can help to identify and address potential problems before they become serious hazards, while also ensuring that the electrical system is operating at peak efficiency. By investing in electrical safety and compliance, greenhouse owners can protect their plants, employees, and property, while also ensuring the long-term sustainability of their operations. Remember, electricity is a powerful force that must be treated with respect. Always take precautions and follow safe practices when working with electricity, and never hesitate to consult with qualified professionals for any questions or concerns. With proper planning, installation, and maintenance, the electrical system can provide years of reliable service, while also contributing to the success of the greenhouse operation. Electrical planning should also take into account the possibility of future expansion. Consider adding extra capacity to the electrical system to accommodate future growth and avoid the need for costly upgrades later on. This can be achieved by installing larger electrical panels, running larger conductors, and adding extra circuits. By planning for future expansion, greenhouse owners can save time and money in the long run. In addition to electrical codes and standards, there are also various best practices that can be followed to improve the safety and efficiency of the electrical system. These best practices include using energy-efficient lighting and equipment, installing surge protection devices, and implementing a regular maintenance schedule. By following these best practices, greenhouse owners can reduce energy consumption, protect their equipment, and ensure the long-term reliability of their electrical system. Another important aspect of electrical safety is proper grounding. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock hazards. The grounding system should be inspected regularly to ensure that it is in good condition and that all connections are tight. Any damaged or corroded components should be replaced immediately. Surge protection is another important aspect of electrical safety. Voltage surges can damage or destroy sensitive electronic equipment, such as computers, sensors, and control systems. Surge protection devices can help to protect this equipment by diverting excess voltage away from the equipment and back to the source. Surge protection devices should be installed at the electrical panel and at any individual equipment that is particularly sensitive to voltage surges. Regular maintenance is essential for ensuring the safety and efficiency of the electrical system. Maintenance tasks should include inspecting wiring, tightening connections, testing ground fault circuit interrupters, and cleaning electrical panels. A regular maintenance schedule should be established and followed to ensure that all tasks are completed on time. Training is also essential for electrical safety. Employees should be trained on basic electrical safety procedures, such as how to identify and report electrical hazards, how to use electrical equipment safely, and how to respond to electrical emergencies. Training should be provided regularly to ensure that employees are up to date on the latest safety procedures. In addition to these specific recommendations, there are also some general principles that should be followed to ensure electrical safety. These principles include always turning off the power before working on electrical equipment, using insulated tools, and never overloading electrical circuits. By following these general principles, greenhouse owners can help to create a safe electrical environment for their plants, employees, and themselves.